In this video, we'll talk about the first of our transformations, which is translation. Translation is basically a move or a shift. When we do this translation, our graph is going to stay the same size and it's going to stay the same shape. All that's really going to change is where does it occur on the graph. So for example, if I start with this figure, which is obviously not a function, it fails the vertical line test, but we can illustrate very easily with this. If I'm going to translate the cat, I just change where it occurs on the screen. I move it around, but it doesn't really change what it looks like, doesn't change how big it is, doesn't change, how tall or how fat it is. That's the translation. When we're dealing with this and a function, if we start off with the function y equals f of x, our translated function is going to be y minus k equals f of x minus h. Or, if we like to solve for y, we're going to get y equals f of x minus h plus k. And in this, the h value is the horizontal translation, and k is the vertical. So when h is positive, means we're going right. When k is positive, it means we're going up, which kind of makes sense with the way we think about things. When you look at the equations, and I'm going to start looking at this red one here, you notice here y minus k, we're subtracting our translation from the y if it's in the y direction, the vertical direction, and we're subtracting from the x if it's in the horizontal direction. Now when we flip it over, so we say we solve for y, the h is still being subtracted, but the k is being added because it's on the opposite side of the y. Think about what variable is it affecting. So we got h affects the horizontal, k affects the vertical. So let's look at a few examples playing with this. So let's look at an example. In green here I have my function y equals m of x, and I have translated it over here to this red version. If you notice, it's the same size, it's the same shape, so all I did was move it. So let's see, how did we move this? So if I go from one of the points on the green, I went up 4 units, and then I went to the right 3 units. So my movement to the right is horizontal, that's my h value. My movement up and down is my k value. So when I come to write the equation for this, I would say y minus my vertical change equals m, because that's my function, of x minus my horizontal change. Or, to solve for y, we'd say y equals m of x minus 3 plus 4. Let me clean up that m a little bit, look a little better. Okay. So, let's try another one of these. If I look at this blue one, again, I'm still the same size, I'm still the same shape. All I've done was moved it again. So again, I take a point from the green one. How does it move to get to the blue? So I'll take this point this time. It went up 2 units, and this one went left 3 units. So we'll say going left is the opposite of going right. So we'll make this time my h, instead of being a positive 3, is a negative 3. I still went up, so my k is still positive. In this case, it's a positive 2. So when I write my equation for this one, my y minus my vertical shift is going to be 2. When I look at my horizontal, x minus a negative 3, because I've moved to the left. This is where we get the plus for going left instead of the minus for going right, the opposite of what we think will happen. So again, we can write this as y equals m of x plus 3 plus 2. So let's try some examples going the other way. So let's again start with my y equals m of x, but in this case, instead of giving you the new graph, I'm going to give you the new function, and we're going to try to graph it. So if I start with y equals, it's doing that, I hate it when it does that, y equals m of x minus 2, and let's go minus 3. If we look at this, x minus 2 means my h value is 2. We're going 2 units to the right. I'm subtracting 3. Now I'm in this form right here. This form right here. So I'm adding my k value. So I'm adding a negative 3. So that means my k equals a negative 3. So this means I'm going down 3. So for each one of my points, I'm going to go right 2 and down 3. Make my new point. Draw a point. Oh, I see what's wrong. So I'll go from this one, I'll go right 2, down 3. From this point here, I'll go right 2, down 3. This point, I go right 2, down 3. And for the last point, I go right 2, down 3. And that's how the dot set define my function, so I can now draw in this shape. And this will be, oh, I'm hitting the wrong thing. There is my translated function. Finally, let's see how this relates to actually writing equations, not just working with graphs. If we notice what we're really doing, we're taking the x, and I did that wrong, so let's undo that. We're taking the x value and replacing it with x minus h. We're taking the y and replace it with y minus k. So when we're working with an equation, it's nice to think of that idea of a substitution. When I do this translation, I'm just going to do this. Replace x with x minus h. And I'm going to replace replace y with y minus k. So if I were to give you a function, let's say y equals 3x squared plus 2, and I want to do a translation, and we're going to go right 5, and let's go up 7. This idea of going right 5 means we're going to replace x with x minus 5. And going up 7 means we're going to replace y with y minus 7. So plugging that into my original equation for y and x, I'm going to get y minus 7 equals 3 times x minus 5 squared plus 2. And this is my translated function. If I want to go ahead and solve that so it's solved for y, I just need to add the 7 to the other side, and I get y equals 3 times x minus 5 squared plus 9. As your equations get more complicated, this is a more complicated procedure, obviously. If we can just replace it with function notation, it's really sweet and to the point. But all we're doing when we're doing that translation, whether we do it using the function notation or we're doing it with the equation, it comes to this idea here. Point. We're replacing the x with x minus h. We're replacing the y with y minus k.